Okay, how to factor polynomials. So the purpose of this video is I'm going to just try to give you some powerful tips on how to factor the most polynomial situations that you're going to come across in algebra or algebra 2 or college algebra, whatever course you might be that involves factoring polynomials. These are going to be the most common situations. Now, I just want to tell you right up front that this is, you're not going to be able to, if you're lost in this subject, if you will, this is going to help you out, but it's not going to be enough. So I have additional videos on my YouTube channel, but if you really need extensive instruction, and I kind of suggest that's the case for a lot of people who are struggling, then you might want to check out my math courses. I'll leave a link in the description of this video if you're interested in learning more from me in kind of in a formal manner. But with that being said, let's get into these four different type of problems that will cover the majority of polynomial situations that you may face in any one of these particular math classes that you might be taking. Now, before you can factor a polynomial, you have to make sure that you can multiply polynomials. So if you don't know how to multiply two polynomials together, like using the FOIL method or the distributive property, then you're going to really struggle factoring polynomials. And I'll say additionally, if you can't factor polynomials, then you're going to struggle. It's going to be impossible for you to pass your algebra class or whatever other math class you might be doing if it involves algebra. So this is an absolutely necessary topic to learn in math. Okay, so I got four different situations here, and let's get into it. And if you understand these four scenarios, then you're going to be able to really handle most polynomial factoring problems that you encounter in algebra. All right, so the first is this problem, and this represents the GCF technique. Now, the GCF is the greatest common factor. You always start when you're looking at a polynomial to see if you can factor out a greatest common factor. Okay, now here you can. So each one of these problems that I have down here are factorable. So if you want to pause the video and just factor them real quick, then then see my answers. That's kind of a good little pop quiz for you. And these are pretty simple problems, so I wouldn't get necessarily too overly confident if you can handle these, but it's a good indication that you know what you're doing. But anyways, let's get into this. The greatest common factor is the first place you always start when you see a polynomial. See if you can factor out a greatest common factor. Now here, what that is the greatest, well, it's exactly what the name says. It's the greatest common factor. So what's common amongst these two terms here in terms of a number? Well, it's 4, okay? And then they have the highest power of x. This is x cubed. This is x squared, but they only share an x squared. There is in common. So you would factor out an x squared like so, and that would leave you with an x right here minus 2. Okay, now if you weren't sure if this was the correct answer, you can multiply these together and you can see you'd get back to this answer. Okay, so this right here, 4x squared, is the greatest common factor. Okay, that is the greatest common factor. Now again, in a short period of time, I'm not going to be able to teach you everything you need to know about the greatest common factor. So you should be somewhat familiar with how to do this. But when it comes to factoring polynomials, this is the number one place you want to start. Okay? So if you don't know how to, if you're not comfortable with factoring out the greatest common factor, I have videos on my YouTube channel. I go into it. Plus, you might need more extensive instruction, so you might want to check out one of my courses. Just check out the link below. Okay, so that's the first scenario. Okay. Now, the second scenario is this. If you can't factor out a greatest common factor, okay, let's say you're looking at a polynomial and there is no greatest common factor, well, that doesn't mean that you're done, okay? What you may have is one of these three remaining situations, okay? So let's just kind of talk about these here. So this is what we call a trinomial. There's three terms, but there's no greatest common factor. This is also a trinomial. There's three terms, but there's no greatest common factor. And the difference between these two trinomials is this one is just a 1x squared. There's just a 1 in front of it. And then this has a number other than 1. So here in this example, this is 2. Okay? So And what we have here are trinomials. Trinomials. So this is where you want to look for next, okay? So you checked out greatest common factors, and you're going to see if there's any trinomials. Now the last problem here that you might encounter is a special factoring scenario. Okay, so just we'll put the word here special. So these four scenarios here, four situations, will cover the majority of your factoring scenarios. Okay, now I'm going to get into these problems, these last three problems here in a second, but I just wanted to just lay out the kind of like your mental organization in terms of, hey, I got to factor a polynomial. Always start with the GCF. If I'm dealing with a trinomial, what type is it? I like to refer to this as a case 1 because there's a 1 in front of it, and then anything else is what we call, like, say, a case 2. All right, and if you don't have a case 1 or case 2, then see if there's any special factoring rules that that could apply to the polynomial. Okay, so let's get into this. So very briefly, case 1 is a trinomial where there's just a 1 in front of the leading, the 1 is the leading coefficient, okay? So when you write it in standard form. So if you look here, the easiest way to factor a case 1, if they are factorable, okay, let me just do it this way, is look at this last number, okay? That's -6. Now, one way I kind of like to start students off a factor in case 1s is to write out all the factors of a -6. So here's how you do, okay? So -6 you can write as 1 times 6, a -1 times 6, right? Will give you a -6. 1 times a -6 will give you a -6, okay? 2 times 3, -2 times 3, and 2 times -3. So these are all the different ways you can write the factors of -6, right? All these numbers, these different combinations, will, when you multiply these pairs together, will get you a -6. Now, if you add up each one of these pairs, what do you get here? You get a +5, right? -1 plus 6 is a +5. 1 plus -6 is -5. This right here is a 1, and this is a -1, right? So when you add all these pairs together. So what you want to do is to see if you have a pair, any pairs of factors that add up to this center number, okay? So this is a 1x squared. This is a +1. So which one of these pairs adds up to a +1? It's these pairs, right? -2 plus 3 gives you a +1. And these are the answers. These are the factors. So you could write this trinomial, you could factor it this way. Okay, you're always going to have two binomials. So it's going to be x minus 2, okay, one of those answers, and x plus 3 right there. So these are the factors to that trinomial. It's as simple as that, okay? Of course, you need to practice this. Now, if you couldn't find any pairs of factors here that add up to that center number, then the polynomial is unfactorable. It's what we call prime, okay? So let's move on to this case 2. Now the case 2, you can do this in a similar manner, but there's some additional steps. But I'm going to give you another technique you can use to try to factor a case 2. Let me write this a little better. I kind of call it the double smiley face. So the first thing is we have 2x squared. So you want to write the factors of 2x squared. There's only one way to factor that, and that would be a 2x and an x, right? So if I multiply 2x and x together, I get a 2x squared. There's no other way I could write that. Now, what we're trying to do here is play a little game to try to get back to this center number. Now, the way we have to do that is write the factors of -5 in this position right here. You'll see how this comes together here in a second. So -5 is what? 1 times -5, or -5 times 1. So I'm going to put this -5 right there, and I'm going to put a 1 right there, okay? Now, if what I'm going to show you doesn't work, I can just kind of maneuver these combinations around because I'm trying to get back to the center number. Now I told you I was going to use something called the double smiley face technique. So what that is you take this number here and you multiply by this, okay? and that's one smiley face, if you will, and then we do this times this. So you can see we have two smiley faces. Let me draw this other one a little bit bigger. Okay, so we have 1x, right? 1 times x is x, or 1 times x is 1x, positive 1x. And then I have 2x times a negative 5, that's negative 10x. Now, if I add these two guys together, you're looking to see which combination gets back to the center term. So if you see here, a 1x, a positive 1x plus a negative 10x gives me a negative 9x. So these factors right here are correct, okay, because of that. And if you wanted to, you can just multiply all this out to verify that, in fact, you have the correct factors, okay? So this is the double smiley face. Now, you could do this problem in a similar fashion as I did this first case 1 problem, but there's some additional steps. So I really like the double smiley face technique for this case 2 polynomials. And for case 1, this technique I showed you here is just really straightforward, okay? So I would suggest using that as well. Okay, so now you have we have three things behind us, right? We have the greatest common factor. We always look there first. Then if we're dealing with trinomials, what type? And if we don't have any trinomials, we don't have any greatest common factor, that doesn't mean that you're done. You may have a special factoring scenario. So if you look here, this last problem, there's no GCF, it's not a trinomial, so what do? Well, in this case, you just need to know the special factoring rules. Probably one of the most important is a squared minus b squared. Oh, let me write this way here. A squared minus b squared is equal to a plus b times a minus b. It's called the difference of two squares. It's used extensively, okay, when we're talking about factoring. So here, the way I would factor this, I would just simply need to know this rule. This is a special factoring rule. So this is going to be x plus 3 times x minus 3, okay? Write that a little bit better. So this is how this factors here, because I know the special factoring rule. Now, again, I'm going to wrap up this video here. No way could I fit in what takes your teacher a couple weeks to teach you. At least the factoring is covered in and over in multiple math courses. So this is a lot of skills that kind of build up. No way should you expect to just watch this video and be like a total expert. But if you have a clue about factoring and you know how to multiply and you're like, oh, you're just kind of struggling or a little bit confused, then I think this video would definitely should have helped you out, right? Because you always start here. You'll always start with the GCF, then you look to see if you have any of these scenarios, and then if you don't, just make sure you don't have any special scenarios. If you follow this, you're going to be good to go in most factoring situations. But again, if you need more help, you want to go ahead and check out some additional videos I have on my YouTube channel, so please consider subscribing. And if you do, hit that bell notification. And if you like this video, hey, give me a thumbs up. I appreciate that. And leave me comments. It's it's one of the things that I try to read it. I do get a lot of comments on my videos, which I'm grateful for. But it gives me feedback on videos that future videos I can make that are going to help you out. Again, if you like my teaching style and you understand, how I teach, and you need extensive help in math, then you might want to consider checking out some of my math courses, and I'll leave a link in the description in the video if you're interested there. But other than that, I appreciate your time and have a great day.